Yes, hi guys. So today I'm talking about now further multiple integrals. Now usage of multiple integrals. We have discussed up now what is multiple integrals. After that we discussed about change of the integration. Okay, so change of integration sign or integration. Then change of the variable as well. Okay, change of the integrals, and after that we discussed about change of the variables. Okay, before that initially multiple integrals double. Now we have to discuss about what is the application of multiple. In case of multiple of integrals, I mean application of multiple integrals or double integral or triple integrals, what is the usage of this? What is the application? Okay, multiple integrals. So in case of multiple integrals, usage of or application of multiple integrals. Today I am talking about mass of the figures, geometrical figures. I mean like if it is a plane lamina. Okay, lamina means the surface area of a rectangle, sphere, etc. Okay, plane areas. So that is a plane lamina. Okay, what is the mass of a plane lamina? We talk about if the curve is given, there is a plane curve. For example, a wire is given, a parabola is given, an arcual length. Okay, if any arc is given, what is the mass of the arc? I mean, okay, or curves. Okay, so arc of the arc or curves. So mass of the curves we will find out. Mass of the solids also are written down here, solids, but solids includes almost all the surfaces which are having solid figures. I mean that means like a sheet, like a plate, like a plate can be circular plate, it can be elliptical plate, or it can be a plate which is just having a plane area, like in XY plane. Okay, so this is a plane surface area. So that is a plane lamina we will talk about. That is lamina. So these kind of masses we have to find out. So what is the mass of a plane area or plane lamina? I mean, what is the mass of a curve given? Density is given to us. So density is given to us. So density into total area, that will give us total mass of that plane lamina. Okay, we are ready. The length of the wire is given. Suppose a curve is given. So the length of the curve and its area, elements of area is given to us. Suppose ds, rho into ds is the total area of the wire or curves that I'll just note down here. And then what is the volume? Okay, first we have to find out the volume of a solid. Okay, solid volume is in XYZ plane. Okay, we are having a solid figure like sphere, like it may be a ellipsoidal also. Okay, ellipsoidal is also given sometimes, or in three-dimensional geometry. Okay, so three-dimensional geometrical figures where solid figures are given, their volumes is calculated. After that, we have to multiply that volume, elementary volume, okay, or this is known as elementary volume, that is d.x.d.y.d.z, okay, or a small element. These kind of elements and number of innumerable number of these kind of elements, okay, are that plane figure or that geometrical figure, any figure, maybe solid figure, is divided into number of elements. So one single element, then that area or volume or length of that curve is given to us. Then we have to multiply by the density of that particular figure. Like solid's density is given at a point p x y z, for example, three-dimensional figure. Then suppose density is rho x by z. In case of a plane figure like plane lamina, xy plane, we are given. So density in this case will be rho x by. Density into area of that. Area of element is d.x.d.y. We have to multiply by rho d.x.d.y, integration of this. Double integration of this, because this is here double integral. Why? Because there are two dimensions here, x and y. So this is double integral. In this case we will use, but in case of a length of a curve, or mass of a curve, the length is given, and we have to find out only integration sign rho into ds. Okay, so that is single multiple sign. Integral sign. That means how to find out the mass of the plane curve. That is how we will find out. Now These questions are taken from the student queries, online queries. I'll solve these questions which are based on mass of the figure given. Okay, whatever figures are given here, I'll verify everything. But first we have to find out the area or volume or length of the curve, and after that multiply by density. Then integrate this, okay, with respect to whatever the limits are given to us. Under those limits, we have to integrate this from double integrals with respect to x, with respect to y, then with respect to x, y, and z in case of solid figures. Okay, so let me take one by one. What is mass of a figure? So first, we will talk about mass of a plane figure. Mass of a plane lamina. Let me talk about mass of a plane lamina. In this case, how to find mass of plane lamina? So, if rho x by be the density, let me give density at any point of the plane lamina or any plane figure lamina. In this case, we have taken a part of this, like a rectangle is given to us. It's an elementary part of this we have taken. Any plane lamina or maybe a rectangle or a sphere or any two-sided figure, okay, or two-dimensional figure. That means a plane lamina, okay, at any point the plane lamina, okay, the total mass therefore, okay, of plane lamina having elementary area as d.x.d.y. So d.x.d.y is the elementary area. For example, if I take plane figure or rectangular figure y dash x backwards, suppose there is a rectangle figure like this. This is the A, B, C, D. Let me take A, B, C, D. Okay. Now here, at this point, x equal to A, x equal to B. Okay, this is C, D. Let me take. This is y equal to C to D. What is the area of this figure? And if I take here elementary figure, let me take elementary figure here. This is elementary figure. The length of this is dy, this is dx. I'm sorry, this is dy and this is dx here. And this is d.x.d.y. The area of this smaller part or element is d.x.d.y. Therefore, total area of this whole figure can be given by the limits. Under these limits, integration of this whole figure. So, what is the area of total mass? Therefore, mass of the element or elementary figure, mass of this elementary figure, this one, d.x.d.y, is equal to rho x/y into d.x.d.y. This is the mass of this small element. Okay, this is elementary mass. Therefore, total mass. Therefore, total mass. Okay, therefore, total mass of the whole, for example, this rectangle ABCD. In this case, the plane lamina ABCD. Total mass of the plane lamina. Let me take here plane lamina ABCD can be calculated under the limits. Okay, for example, if I take x limits first, which is a to b, from a to b, under this a to b, okay, and then c to d by limits, and rho dx/y or rho is the density of the figure at point x/y into dx/dy. This will give the total mass. Let me write here capital N. This is what we have to find out, the total mass of the given figure. Now, in this case, it's a plane figure. For this plane figure, we have to find out this area, first area, and then multiply by density per unit, okay, of that area. per square unit or whatever unit is given. Okay, so density is mass of that. Mass of that. I mean per length or per square length or whatever area. If it is area, then per square length. Okay, so that is mass of that. That means density. Density per unit. Okay, so multiply by density, total mass can be calculated. This is mass of first type of question we will discuss about. Second is, I'll discuss about second type. What is mass of plane lamina? What is it? What is or mass of a plane curve? Let me write here. Of a curve. Of a curve. Okay, plane curve or curve, simple curve. Plane curve. Or let me take arc. Plane arc. Yes, arc. So plane arc we have to find out. But plane arc here. So plane arc or curve. So what the plane arc or curve? If I find out, suppose there is a wire which is in the form of a cardioid, let me take in the plane of a cardioid. This is the wire. This length total. You have to find out the area of this hole. I mean within this. Then what the in this case what is the length of this? Okay, so rho is suppose rho is the density of this point. If rho is the density again of the arc okay, ARCH of the arc, okay, the density of the arc or basic curve. Let me take elementary curve of the elementary curve. So rho is the density of the elementary curve per unit. Then total mass and total mass of the suppose area of that elementary arc or curve is ds of the total mass of the elementary total mass of the wire or of the arc. Let me write that here. Okay, of the mass of the elementary, not elementary, mass of the curve, therefore is equal to, this is rho into ds. This is total length, total mass of M, capital M here, like this. This is total mass of the arc or the curve. This curve is given to us. Our arc will share a single length. This single length is given. Suppose per unit of this length, this arc. Okay, we have taken ds as the area into rho into ds. Only single this integration sign will serve the purpose of this length. This we have to find out the mass of this curve. This is the elementary mass of the curve or plane curve. Here it is arc here. Plane arc. Sorry, not arch, but arc. Mine was somewhere else. Okay, so this is arc. So this arc, suppose I have taken here. This is x-axis, this is here, this is y-axis. Okay, so this is cardioid shape of wire. A wire we will take here. One example is given here. The wire is in the form of a cardioid. This is this kind of figure. I'll talk about this question here. Okay, so this the mass of this will be. We will find out what is the rho. Suppose rho density is given. Whatever rho is given here, conditions are given. That rho is given like this. Density of the given figure or given curve is like this. Then find out the mass of the given wire. Here in this fifth question, the wire is in the form of a cardioid R equal to this. If the density at any point of the wire is proportional to its distance from the pole, Okay? And find the mass of the wire. Then mass of the wire will be of this a wire type or arc type of question. So mass of a curve, okay, mass of a curve or plane curve or arc is know the density of the element, okay, not element, but density of the given curve, okay, per unit. Then total mass of the curve will be rho into, this is rho, here density. And rho represents density. Rho is the density here. This is pronounced as rho, okay, rho like this. Not a P, but rho. So this is the second type of question we will discuss. The third type of question, mass of solid figures. Where mass of a solid, mass of a solid, okay, solid. Suppose there is solid given to us, then what is the mass of the solid? So let me find out the mass of the solid. If okay, the rho is the, again rho is the density. Let me take rho x by z. Let the rho x by z be the density, of a solid, figure, like, let me take sphere here, like this sphere, okay, sphere, cylinder, or anything, okay, like a sphere, etc. Then the mass of the solid will be given as triple integral sign, or this is volume integral, triple integral sign rho, which is at x by z, into dx dy dz. Here, in case of three-dimensional figure or solid figures, okay, volume will be given here. The volume is d.x.d.y.d.z of an element figure. Then total integral, okay, 3 times integration will give us the total mass and the rho into this. So rho is the density per unit. That figure, what kind of figure is given here? Per unit of that figure, solid figure, the density is given. The density into the total volume of that figure will give us the mass of the whole solid figure. Okay, so that is this kind of figure. So these are the 3 types of questions. Mass of them are required: 2-dimensional figures, 3-dimensional figures, and a single dimensional figure. That means arc length or arc length of a wire or length of a curve, plane curve. The mass of a curve or plane curve or arc, rho is the density of the elementary curve per unit. Then total mass of the curve or arc is given by rho into ds. ds is the elementary, okay, area of the wire. Suppose this is the curve here or wire here, like this. Sixth figure is 6 questions here. These 3 kinds of questions I'll discuss. Mass of these figures is the basic topic of today. Okay, so what's the application? Further application I'll discuss about the next topic. I mean the next lecture series. I'll talk about what is the area, okay, area of the figures, area of the solids, area of the, okay, what you call 2-dimensional figures, etc. So area application in case of finding out the area of figures, geometrical figures, that is with the help of multiple integrals. Multiple integrals are used to find out mass of a figure, mass of a geometrical figure. It may be curve, it may be plane lamina, it may be a solid figure. In this way, mass. Then the center of gravity also is one of the applications. We will discuss about that also. Center of gravity, okay, or center of gravity, or then volume, as well as volume to find out volume of solid figures. Volume is the application. Then area, after mass, I'll take area, then volume, then CG, center of gravity, and after that, moment of inertia is also given. Okay, so all these topics which are application of multiple integrals. Multiple integrals are used to find out these kind of, topics, yes, like mass, area, volume, okay, then center of gravity. How to find out center of gravity of a plane figure, of a curve, or of a curved figure? In this way, these are the applications. So all these applications are discussed one by one, but today I'm taking mass of a geometrical figure. It may be curve, it may be plane lamina, it may be a solid figure. I have written here solids only, so I'm sorry. It may be solids, curve, it may be curve, I'm sorry, curve or plane lamina. It may be plane lamina also, or surfaces, okay, areas. Or after area we find out. These are the three kinds of topic questions we are going to discuss today. Let me now discuss about these questions. Okay, so this is the process of doing the questions, how to find out. If density is given, then we find out area, and after area into the density will give us the mass. And if volume is given, then volume into density will give us the mass of that figure. Let me take these questions one by one, so that this topic will be very clear after that. Okay, so now first question, what does it say? Find the mass of a plate. Find the mass of a plate in the form of a quadrant of an ellipse. Ellipse is given x square from a square by y square from b square is equal to 1. Okay. Density of which per unit area is given by rho equal to kxy or lambda xy, where k is constant of proportionality. Okay. Where rho is proportional to x into y, so rho equal to k into xy, lambda into xy. If I take lambda into xy or k into xy, where lambda or k is the constant of proportionality. Okay, so that is not a matter of discussion. Now question is this. Now let me take this question. What is given to question number 1? It says if there is a positive quadrant, it says, let me take the geometrical figure. It says this is O, this is Y axis. It says only a positive quadrant of a positive quadrant of a ellipse. Okay, so this is elliptical figure. Ellipse. Now this ellipse is here. It is. Let me take like this figure. Notes uppermost. Okay, so what are the points here? Here it is. Suppose A0. This is B0. I'm sorry, 0B. This is 0 and B. B is this coordinate, and x or this x coordinate is x equal to A here, y equal to B here, this is y equal to B. This is what you call, so what is the equation? X square upon A square plus y square upon B square is equal to 1. This is elliptical figure is given to us equal to 1. X square upon A square by square to B square equal to 1. The density per unit area is given to us. What are the given here? Let me write here. For the process what given is what? First, whatever given to us is to be wrote down. Density, what is given to us, density. Find out the area, then put the double integral or triple integral or single integral. After then multiply by density, you will find out the mass of the figure given. Now in this case, two-dimensional figure. X and y coordinates are given. X and y is two-dimensional figure. Now if I take this is, as I discussed about in case of changing the variables. When changing the variables, how do you find out? This is the strip along the parallel to the y axis. So y coordinate will be here y equal to 0. Here on the ellipse, what is the y value of y? Here y value of y is, from this if I find out, be 1 minus, let me write here, 1 minus x square upon a square equal to y square, or y is equal to under root, that means b upon a under root or square root a square minus x square. How this is? If I take this is from here, y square from b square equal to 1 minus x square from a square, or a square minus x square upon a square. This is y square upon b square. Therefore, y is equal to b, is b upon a square root a square minus x square. This is y on this okay, arc of the ellipse, or on this, okay, on this arc of the ellipse. On this arc of the ellipse, we have value of y as this. What is the value of x? So x limits are at this point 0 and x equal to a at this point. So along this x equal to 0 to x equal to a, limits are these. So density given to us, given ellipse x square plus x square upon a square plus y square upon b square equal to 1. Density given to us, rho is equal to k into xy. Let me take it as k into x into y. This is given to us as density. Density kxy. Okay, k is a constant where k is a constant proportionality. Density density of which per unit area is given by, this is per unit area, k rho equal to k times xy, where k is the constant of proportionality, where k is the constant of proportionality, constant of proportionality. Okay, so k constant of proportionality, rho is proportional to xy. That means density is always proportional to the area, in this case area, or length if it is given. Okay, if the solid figure is given, then it's proportional to the volume of elementary figure. So this element, if I take one element, that element is given as d.x.d.y. So now let me take one total mass. Therefore, elementary mass, let me find out first. Elementary mass of an element is equal to rho into, this is rho into d.x.d.y. Rho is here density, but rho is equal to k into xy. So we will put this, therefore total mass of the quadrant of the ellipse, this quadrant of the ellipse, in this case this quadrant, we will find out this total mass, mass of only this quadrant. Okay, or this quadrant means lying in the only first quadrant, this one, in this figure. So of the quadrant of the ellipse, is mass equal to, total mass equal to double integral sign. First let me write here x limits, where x equal to 0 to a, which I have calculated here, 0 to a here. Okay, and then y is 0 to, y equal to 0 here, y equal to 0 to, y equal to b upon a square root a square minus x square. Now this is a plate here. It says, and the mass of a plate in the form of a quadrant, this is type of plate is given to us. We will find out the mass of this. The quadrant of ellipse, this, the density of which is per unit is, density of which is of per unit area is given by rho equal to this. Okay. Now let me write rho xy, so rho into d.x.d.y. First we have to write like this, but rho here is given to us as, let me write here as 0 to a, sorry, this is a here, then 0 to by 0 to y equal to b upon a square root a square minus x square. A rho is k into xy into d.x.d.y. Now let me integrate them. This is double integral sign, so use of multiple integral. We are finding, this is solution we are finding out. Solution. This was given to us density and only this ellipse. Equation of the ellipse was given to us. So let me find out the total mass. Therefore, mass equal to mass of this equal to 0 to a x coordinates. Now first we have to integrate it with respect to y. Okay, so this is y Let me write here k into x, because this is by limits of y coordinate, limits of y variable or y coordinate. So we have to integrate this with respect to y first, goal sorry with respect to x and sorry with respect to y, sorry, because the limits of y are in terms of x. We have to integrate it with respect to y first. So integration of, let me write here, y into dy 0 to b upon a square root a square minus x square. Let me put that into a bracket, then dx. So integration this with respect to y we have to write here. Okay. So finally, with the value of this, this is 0 to a. Here let me take constant which is outside, k here. X into integration of y is y square upon 2, putting the limits 0 to b upon a under root a square minus x square into dx. Okay, now let me put the limit here. This is k into 0 to a x within x. This is only square root is cancelled out. Only square root is cancelled out, and this is b square upon a square. It will be b square upon a square within bracket. Okay, so within bracket here, this is a square minus x square into dx. First I have to multiply by x inside. B square upon a square, let me take constant. K into b square upon a square outside. First I have to multiply this by x inside. It will be sign of integration 0 to a square x first a square into x minus x cubed. Now this to be integrated with respect to x. So this b square upon a square we have taken common, which is constant. Now let me integrate this. This is k into b square upon a square. Integration of x is a square constant as it is. This is x square upon 2 minus x4 upon 4. x3 integrated as x4 upon 4. Now limits are 0 to a. Finally, let me substitute the limit. The first k into b square upon a square is already there. Now inside, if I put a only, because at 0 it is 0. If I substitute the lower limit 0, then x0 0. It will be cancelled out. But at a, this is a square into a square, that means a4 upon 2 minus a4 upon 4